All right, good day, ladies and gents. Today we're going to be doing the study guide. So a couple of things that need to be on your desk, obviously the study guide, but other things that might will probably help would be your calculator, a couple of different colors of pens or pencils, and definitely you want pages 1, 2, 3, and 4 of your notes to be out on your desk the entire time. The other thing that you need to remember is anytime you hit something, you're like, you know what? I'm going to forget that. That's really important. Add it to pages 1, 2, 3, and 4. So somewhere in the blank spots, if there's something that is super important and you're like, I need to remember that, write it in there. These are your notes. So it would be great to have little things that you need to know in those blank spots. All right, so let's just get started. Okay, so first of all, let's go ahead and do number 1. All right, so find the sum. All right, so that would be at the bottom of page 3. On the bottom of page 3, we have these little notes. So interior, exterior, and here are the steps. Ask yourself, is it interior or exterior? That would narrow it down to 2 choices. Is it sum or regular? And did they give you the angles or sides? And please remember, regular means that all sides are equal and all angles are equal, and n is the number of sides. And if you don't have that written down, write it down now. All right, so find the sum of the interior angles of a 35-gon. Okay, so did they say interior or exterior? They said the word interior. So it narrows it down to these 2 choices. Of all 5 equations, it narrowed it down to these 2. Did they say sum or regular? They said the word sum, so it's going to be this equation. So let's write that down. Sum of the interior equals n minus 2 times 180. And then the next step is, did they give you the angle, which will replace the left side, or did they give you the number of sides, which will replace n? They said it was a 35-gon, so that means that n, the number of sides, is 35. Right. So let's plug that in. So sum of the interior, well, actually, sum of the interior, that's what we're looking for. We're looking for the number of angles, so let's just call that x. So x, because they say find the sum of the interior of the angles, so x is equal to 35 minus 2 times 180. And when you put it into the calculator, 35 minus 2, you get 33, times 180, you get 5940. So x equals 5940. And that is your answer. Okay, let's go to number 2. Number 2, so same steps. All right, so if the sum of the interior of the angles is 3780, how many sides do you have? So they said, so did they say interior or exterior? They said interior. So interior. And did they say sum or regular? They said sum. So we want the sum of the interior. So that would equal n minus 2 times 180. Now, did they give you the angles or did they give you the number of sides? They gave us the angles. So that's what replaced the left side. So 3780 equals n minus 2 times 180. So you have a couple of different choices that you can do now. There are a couple different ways how to solve this problem. So you get to choose whichever one you like. So one way to do this is just to keep plugging in random numbers until you find n. So let me give you a couple examples. So 3780 equals n minus 2 times 180. So that is our equation. So what we could do is just plug in some random numbers. So what if I said n equals 10? If I put n equals 10, so 10 minus 2 times 180, I would get 1440. So 1440, and that's not the number we wanted. We want 3780. So let's go a little higher. How about n is 20? So if we put 20 in there, we get 3240. Still not quite there yet, but I'm pretty close. So just keep plugging in numbers. How about 21? So if we put in 21, we get 3420. Getting closer. How about 22? 3600. Nope. How about, oops. How about 23? 3780. That's the one I wanted. Excellent. So this is, you just keep plugging stuff in until you get it. So n is 23. That's the one I wanted. So 23. So n equals 23. That's the one. So that was one way how to do this. Keep plugging in random numbers, number of sides. You can't be a decimal because it's sides, the number of sides. You can't have 2.3 sides. So that's one way how to do this. So that's option 1, or option A. Okay, another option that you could do, another way that you could do this, so 3780 equals n minus 2 times 180, is actually solve it mathematically. So how would you solve this normally? Well, some people are like, well, I want to solve this, but the parentheses are throwing me off. All right, let's get rid of them. How would you get rid of them? You would distribute. So distribute, you throw that in there, that's 180n, and that would be minus 360. Now you're in familiar territory. You would just add 360 to both sides. So 3780 plus 360, that is 4140 equals 180n. Divide by 180, and you get 23 equals n. So that's another way how to do this. And even a third way, because there's a bunch of different ways how to do this. A third way, so option C, is still to solve this, but some other people saw that you could just have divided by 180 right off the bat. So another way to do this was, okay, I want to solve for this. So we're going to divide by 180 on both sides. So 3780 divided by 180. So those cross out, and we're left with 21 equals n minus 2. You add 2 to both sides, you get 23 equals n. So you pick whichever way that floats your boat. All three of those ways worked. So all three of those ways were A-okay. So you solve this any way you like, dot, 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 and you got n is equal to 23. And that was your answer. Okay, so I just did dot, dot, dot because all of my work was on these other pages. So you just pick whichever option you like best. All right, number 3. All right, so number 3, going through the same motions. Okay, are these interior or exterior angles? They are interior angles. Are they sum or regular? So they are not all the same. There's no proof that all these sides were equal or all these angles are equal. So this would have to be sum. So sum of the interior equals n minus 2 times 180. Okay, so we're going to add all of the interior. So I'm just going to start at a corner. I'm going to start right here. And I'm going to go in a circle and add up all the x's, and then I'm going to add up all the constants. Okay, so starting here, I'm going to add up all the x's. So 10 plus nothing plus 9 plus 7 plus nothing plus 9 plus 8 plus nothing. And I get 43. So we have 43x. Now let's add up all the constants. Negative 11 plus 121 minus 17 plus 6 plus 153 minus 14, and then plus 15 plus 139. Okay, and we get plus 392. Now there were a lot of numbers, so you probably want to do that 2 or 3 times just to make sure that you get the same number. That's a suggestion. Is equal to n. Hey, n is the number of sides. number of sides or number of angles. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I just counted the corners because that's the same number. So 8 minus 2 times 180. So 43x plus 392 equals, and then I put in my calculator 8 minus 2 times 180 degrees. I get 1080. Okay, and then you just keep solving. So you're going to subtract 392 from both sides. You get 43x is equal to 688. Divide by 43, and x is equal to 16. And then you would plug it in just to double check that you didn't get any negative numbers. But I'm just going to tell you that that's good to go. So, and make sure you answered their question. So if you see angles A, B, C, D, or anything like that, make sure you read that. So they did want x, and x was 16. So that was your answer. Fantastic. Okay, number 4. This should look super familiar. You've seen this a couple of times. Okay, the figure below represents the octagon. Okay, octagon. That means n is 8, meaning that you have 8 sides, or you could have just counted. Shaped pool with a deck built around it. Each section of the shape of congruent isosceles trapezoids. So all these little sides are equal to each other, right? Okay, what would be the measure in angles of the angle marked x? Okay, so let's just go through the motions. Is x an interior or exterior? That's interior. Is it sum or regular? They said congruent isosceles, so that's regular. Is equal to n minus 2 times 180 divided by n. All right, so let's just focus on the right side for a second. So there are 8 sides, so 8 minus 2 times 180 all over 8. And then when you put that in the calculator, you get 135. Now the entire angle is 135. This entire angle is 135. So look at it this way. This part right here is x, and I know this entire angle is 135. But x is only half of it. So there's another x over here. There's another x right here. So if this is 135, what would this have to be? You would just divide by 2. So 135 divided by 2, this would be 67.5. This would be 67.5. So basically we had x and x. So there's basically 2x right here. That's what's going on. So now you would divide by 2. And x would equal 67.5. Or you could have gone straight from 135 and gone to 67.5 because it's divided by 2. So I just showed more work than I needed to. All right, boom. There's that problem. Better know that one. All right, number 5. Number 5, the exterior angle of a regular polygon. So exterior of a regular is 24 degrees. How many sides? So you're looking for the number of sides. Okay, so they said exterior, so it narrows it down to these two, and they said regular. So that's this equation right here. So regular exterior equals 360 over n. Okay, they gave us the angle, so that's going to replace the left side. So that would be 24 is equal to 360 over n. All right, and then all you have to do is put this over 1, cross product. So n, so we're getting rid of the division of n, so we're going to multiply it onto the other side. So 24 times n equals 1 times 360, which is 360. I ran out of room, so I'll put it up here. 24n is equal to 360. I'm going to divide both sides by 24. And n would equal 15. And that's what they wanted. How many sides? So the answer is 15. All right, let's keep going. All right, number 6. What is the measure of each exterior angle of a regular nonagon? Nonagon. Okay, so we want regular. So they said the word regular and they said the word exterior. So regular exterior equals 360 over n. And they want the angles. What is the measure? They want the angles. So they're looking for the angle, so let's call it x, is equal to 360 over a nonagon. How many sides are in a nonagon? 9. All right, so 360 divided by 9, and you get x is equal to 40. And that is your answer, 40. All right, next. Okay, number 7. Okay, so you see how there's letters? You got to be careful because they're going to probably ask something weird. So in our case, they're just going to ask for x, so that's awesome. All right, so here we go. Okay, are these interior or exterior angles? They're exterior. Are they regular or sum? There's no proof that these are equal to each other, so we're just going to use the word sum. Is equal to, that's just 360. So sum of the exterior is 360. So please notice that having out page 3 is very helpful. All right, so we're going to add up all of these. So I'm just going to start right here. I put a little dot there so I know where I started. Okay, so go around in a circle. So we're going to add up all of our x's. 9 plus 4 plus 7. We get 20. So that's 20x. We now add up all the constants. Negative 31 plus 33 minus 2. Ooh, we get 0 is equal to 360. So that's basically just 20x equals 360. Divide by 20, and we get x is equal to 18. And that's what they wanted. But you should probably plug it in just to double check because they might ask for one of these random angles. But that's our answer. So x is equal to 18. All right, number 8. So number 8, we have this shape. Okay, so now this is a parallelogram. So we want to have out the parallelogram rules. So that'd be page 1. Okay, so we have 115. It's the same thing as this angle right here. And we know that if this is 115, all of this is 115. All right, that's good to know. So all of this is 115, all of it. So you might want to put it out here, or you might want to put a rainbow saying, ooh, 115. You do what floats your boat. Now this did not get cut in half. This and this are not equal to each other. There's no proof of that. However, do you see this triangle right here? I'm just showing you just a little better here. So this is a right angle. So that's 90 degrees here. And this is 35. So this is 90 degrees. This is 35. What would be the missing angle right there? So we know, I'll put a little dot. So 35 plus 90 plus that dot is equal to 180 degrees. So 180, we're going to subtract the 35 and the 90, and we're left with that little dot is 55 degrees. So this right here is 55. All right, so if this is 55, what's left over to make 115? Okay, so that's the next step. So our next step would be 55 plus our x is equal to 115. So 115, make sure you're doing 115 and not 155. So 115, subtract 55, and x would have to be 60 degrees. So this right here would have to be 60 degrees. All right, fantastic. Okay, so, and that is our answer. All right, okay, so let's flip the page. All right, we are now on page 2 of our study guide. All right, here we go. Number 9. Okay, so find the indicated measure of the parallelogram. So we're looking for n. All right, so all of this should actually look familiar. So looking at the rules of parallelograms. Okay, so we have these two angles, right? So on a parallelogram, so I'm just matching to the picture, these two angles, nothing. Those two angles, nothing. Those two angles. Oh, they're supposed to be equal to each other. And if you still weren't sure, hey, it doesn't B equal B. So you could use either one of these to help you out. Okay, so those are equal to each other. So 8x plus 17 is equal to 12x minus 39. All right, we're going to subtract 8x from both sides. So 12 minus 8 is a 4x minus 39 is equal to 17. Sorry. All right, we're going to add 39 to both sides. So 17 plus 39, we get 56. So 56 is equal to 4x. Divide by 14, and we get x is equal to 4. So x is equal to 4. Now, plug it back in. If you have letters up here, plug it back in to double check yourself. 8 times 4 plus 17, you would get 49. 12 times 4 minus 39, we get, so I'm seeing something wrong, right? So when I plugged in 4, so 12 times 4 minus 39, I got 9. I'm like, wait a minute, something's wrong. You want to know what happened? I wrote 4, it was supposed to be 14. So I caught my mistake. So I thought it was this pretty number 4, but it wasn't. It was 14. I dropped a 1, so let's try that again. 8 times 14 plus 17, that's supposed to be 129. And then 12 times 14 minus 39, that's 129. Okay, so you just saw me catch my mistake. I thought it was 4, it was 14. Okay, so when you plug it back in, this right here disappears, that's 129. This right here turns into 129. And what would be the other angles? So we have this angle and this angle, and I want this one. So let's look at the rules. So I have these two angles, I want that one. No, that doesn't help. These two angles, I want that one. Well, those are singles and that's a double. I don't know what the frick that means. All right, keep going. I have these two angles, I want this one. Well, look, if I have B, I can find A because they add up to 180. All right, so if this is 129, so N plus 129 would equal 180. So subtract 129 from both sides, and N would equal 51. 80, yes. So this is 51, and this is 51, and that's what they wanted. N is equal to 51. Okay, keep going. Number 10, same thing. So we have these two angles, so let's match it up to our picture. If I have these two bottom angles, okay, nothing, double and single, that doesn't really help. A and B. So if I have A and B, they add up to 180. So notice I'm matching up to the picture to help me figure this out. So these two add up to 180 degrees. So 5x minus 6 plus 14x minus 4 is equal to 180. And now we solve. They're on the same side, the equal sign, do the same operation it says. So 5x plus 14x is a 19x. Negative 6 minus 4 is negative 10, is equal to 180. Add 10 to both sides. 19x equals 190. Divide by 19, and x would equal 10. Awesome. But they wanted r. So remember, I taught you to always plug it back in to double check yourself and to answer any question. So 5 times 10 minus 6, this would turn into 44. 14 times 10 minus 4, we get 136. And those two add up to 180, so I feel good about that. So this disappears, and this is 44. This disappears, and that's 136. And you could be able to find all the angles. Over here, these two would be equal to each other. This would also be 44. These two would be equal to each other. That's 136. And what did they want? They wanted angle R. So R is equal to 136. And that's your answer. All right, let's keep going. You guys doing great? Hopefully you're copying down everything we're doing. All right, here we go. If PQRS is a rectangle, so let's go ahead and get out our rectangle rules. So here are our rectangle rules on page 2. So first of all, it's parallelogram first and foremost, but then there's these 3 extra rules where every angle is 90 degrees, the diagonals are equal to each other, and all 4 of these little parts are equal to each other. Okay, and they said that P to R, that's the whole shebang, so I'll write it out here. So it's 10x plus 8. And S to T, that's just this little part, is 4x plus 6. Okay, now if we know that this little part is 4x plus 6, so on our rules, that would be just like this one. If this is 4x plus 6, then all 4 of them are 4x plus 6. So let's just write that. 4x plus 6, 4x plus 6, 4x plus 6. And be careful, that sometimes my 6 looks like a 4, so I'm going to make that prettier? There we go. Okay, and let's find x. All right, so this right here, the whole shebang is 10x plus 8. So this plus this equals the whole shebang. So I'm going to have 4x plus 6 plus 4x plus 6 equals the whole shebang, 10x plus 8. All right, that would be, when they're on the same side, do the same operation, 8x, and that would be 12 is equal to 10x plus 8. I'm going to subtract 8 from both sides. I get 12 is equal to 2x plus 8. Minus 8, I get 4 is equal to 2x. Okay, and then we divide by 2, and x is equal to 2. All right, so that's what I got. I want to double check and plug everything back in. 4 times 2, and then plus 6. This would be 14. 4 times 2, well, obviously 14. And then, let's see, 10 times 2 plus 8, 28. Does 14 plus 14 equal 28? Yes. So I feel really good about this. So this disappears. This is 14. This is 14. This is 14. That's 14. And all that would add up to 28. All right. And let's answer the question. They wanted just x. I feel really solid about this. X is equal to 2. All right. Number 12. All right. So on number 12, the figure below is a rhombus. So let's look at our rhombus rules. A rhombus is basically a square knocked over. So we have, so not only are the parallelogram rules true, but in addition to that, we have these 3 extra rules. All 4 sides are equal. The middle is 90 degrees, and the diagonals are angle bisectors. They bisect the angles. So these 4 are equal when they got stabbed, and these 4 are equal when they got poked. Okay. All right. So let's see. They said A to D, so that's right here, is 4x plus 2. D to C is 7x minus 13. And B to D, that's the whole shebang, is 34. Okay, so let's find a couple things, shall we? All right, so I know I had these 2 sides right here, so I want to find x. So these 2 sides on our rhombus match up with this. And notice how they both have singles. So that means that they would be equal to each other. So these would be equal to each other. So 4x plus 2 is equal to 7x minus 13. All right, solve. Subtract 4, we get 3x minus 13 is equal to a positive 2. Add 13, we have 15 is equal to 3x. X equals 5. Plug it back in to double check yourself. 4 times 5 plus 2 would be 22. 7 times 5 minus 13, good, we got 22 again. Feel really solid about this. So this right here disappears, that's 22. That's 22. And remember, if we have this one side, we have all 4 sides. So all these sides are 22. All right, what else do we have? Well, this is 34, right? All that was 34. And I know from the rules of, at the very least, a parallelogram, if we go back to a parallelogram, diagonals, this and this would be equal to each other. So if this is 34, then this right here is 17, and this right here is 17. Okay, and they wanted A to E. They want this. All right, now we know this is a right angle right here, 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 and here. Okay, that's part of the rules for a rhombus right here, right angle. So when they have a right angle, you have a right triangle somewhere. So be mindful of that. So we're going to be using the right triangle right there. I'm going to write the 17 out here because it kind of disappears. All right, so looking at the right triangle, this is 17, this is 22, and I want this. So I can call it X, or I can call it B or A, whatever. I'm going to just call it X, even though it's not really X. Just calling it that. All right, so we want A squared plus B squared equals C squared. Your C is always your hypotenuse. C is always the biggest side. So we have 17 squared plus X squared is equal to 22 squared. All right, 17 squared is 289 plus X squared equals 484. I ran out of room, so I'll put it up here. I'm going to subtract 289 from both sides. So 484 minus 289. I get 195. So x equals 195. Or sorry, x squared. Square both sides. X is equal to 13.9642400. Okay, so a couple things you need to know. If they asked you for just this little part, you would actually write down the A to E. You would round it, right? So that would be, they said to round to the nearest anything. Did they say it? Let's see. Find anything. Let's just go. They didn't actually say to round to anything, so I'm going to go to nearest hundredth. So that would be 13.96. But if they said that they wanted A to C, I'm just pointing that out. If they said A to C, you would not add, you wouldn't multiply this by 2, you would multiply this by 2. So multiply that big long decimal by 2 if they were asking for this big long distance. All right, so now, and then that would be this big long decimal, which would be 27.93. So notice if I take 13.96 times 2, I wouldn't get 93. I would get 92. So whenever you're doing the work, you want to make sure that you do the big long decimal if you're still working. Round to the very, very end. Just point that out. Anyway, we got our answer is 13.96. That was our answer. That's what they wanted to know. Let's move on. Okay, 13. Okay, so once again, this is still a rhombus. So we have this angle, so we actually have all of those angles. So if this is 36, that's 36, that's 36, that's 36. We also know that these are 90 degrees. Excellent. Okay, just pointing that out. But here's the thing, they didn't even want those angles. What they wanted was the perimeter. Okay, they want the perimeter. So let's go ahead and just keep going. So we have M to K. M to K, all of that is 20.4. And they said J to L, that's the whole shebang, is 26.2. And I know that these suckers got cut in half, so 20.4 would really be 10.2 and 10.2. And 26.2 would be 13.1 and 13.1. All right, sweet. And they said K to L is 16.6. So that means all of these are 16.6. All right, so they want the perimeter of this triangle. All right, so they want the perimeter of J, N, M. So they want this sucker right here. So they want this. All right, so that's pretty easy. Just add up all the sides, right? Just add up all the sides. So we have 13.1 plus 10.2 plus 16.6. Add those together. So 13.1 plus 10.2 plus 16.6. That's perimeter. We get 39.9. Let me just double check I read everything correctly. They said M to K, 20.4, which is 10.2. Yes. J to L, 26.2, 13.1. And K to L, 16.6. And you add all those together. Yep, I feel really good about that. So our answer is 39.9. And there you go. All right, let's keep going. Okay, so number 14. So on number 14, we have DEG, FG is a rectangle. So this is a rectangle. So we're going to have the rectangle rules right in front of us, which is on page 2, all those rectangle rules, which in addition to our parallelogram rules, these are right angles, the diagonals are equal, and all 4 of these are equal. All right, so we have that. All right, so they said angle DEG. So we're at E. So I don't know if I'm talking about the top, the bottom, or the whole shebang. So DEG. So this angle right here, so that would be the top angle. So is 4x minus 5. They also said angle G. So once again, I don't know if I'm talking about the top, the bottom, or the whole shebang. So FGE. FGE is down here at the bottom, so that's 6x minus 21. All right, and what do we know about those angles? Now, this is a rectangle, right? So if this is a rectangle, but first and foremost, this is a parallelogram, right? So on parallelograms, we can do the Z thing, right? We can do the Z. So this angle here is equal to that angle right there. Those are equal to each other. So let's do that. So these angles right here are equal to each other. So we have 4x minus 5 is equal to 6x minus 21 because of alternate interior angles. So you can do the Z, alternate interior. Okay, subtract 4x, you get negative 5 is equal to 2x minus 21. Add 21. So negative 5 plus 21, you get 16 is equal to 2x. X is equal to 8. All right, so we have x is equal to 8. Plug it back in. 4 times 8 minus 5, you get 27. 6 times 8 minus 21, I also get 27. So this is 27 degrees, and this is 27 degrees. And let's keep going. They said that they wanted angle G. Now, I don't know if I'm talking about the top, the bottom, or the whole shebang. They said DGE. So they want this. Oh, those tricky little buggers. Now, what do we know about this entire angle? It's a rectangle. That entire angle on a rectangle is 90 degrees. So all of this, so that dot plus 27 is equal to 90 degrees. So 90 minus 27, and that dot is 63 degrees. That is your answer. All right, awesome. So if you need to take a quick little break before you start the next part of the video, I would suggest that. All right, so take a break. Give you guys, you want to just pause the video, go for it, and then we're going to start number 16. Okay, so hopefully you took a quick little break. So let's go ahead and go to number 16. All right, so on number 16, so given the regular polygon, so regular, the coordinate grid, what's the transformation, will place the figure back onto itself. All right, so let's just try a couple things. Okay, if we reflect over the y-axis, so this right here, if we reflect it over the y-axis, this would be 1, 2 hops away, 1, 2 hops away. So yes, this reflecting over the y-axis does feel smack dab in the center of that. So yes, that works. Okay, we're going to skip this one for a second. Okay, how about y equals x? So that is a diagonal, and it's a positive because it's a positive x. So here, 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 here. Okay, so does that look like you cut that sucker in half? No, because look, if I flip this over this line, it would land right here, and I didn't land on this shape, so that didn't work. So that's no good. All right, how about 240? Okay, so the rest of these are going to be angles. Okay, so this is something important you probably want to put on your page. So let's go ahead and put it on page 2. On page 2, because we already put some extra notes. So when we're doing rotation, we want the multiples of regular exterior. So, so for example, if we have 8 sides, so we would do regular exterior equals 360 over n. So 360 divided by 8, and we would get 45, right? So we want multiples of that. So 45, 90, 135, 180, 225, 270, 315, and 360. All right, so and then you go dot, 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 because you would keep going. So those are multiples of the regular exterior. So any one of those numbers are good. In our case, we have 6 sides. So we want the multiples of regular exterior. And we know that we're going to need to know that. That's why I put it on my Hot Topics page, my first 4 pages that are going to stay in front of me the whole time. So multiple exterior. So we have regular exterior equals 360 over n. So we want 360 over, how many sides did you have? 6. So 360 divided by 6, we get 60. So we want multiples of 60. So that would be 60, 120, 180, 240, 300, 360, and you would just keep going after that. Okay, so is 160 on that list? No, it's not. Is 60 on that list? Yes, it is. Is 240 on that list? Yes, it is. So all of those are good. Okay, so that was really important. You guys need to know. All right, so make sure you have that on your Hot Topics page to help you out. All right, number 17. Okay, so before we start, we need to actually plot this. Okay, so to help me recognize where the axis lines are, see where the arrows are, I'm going to darken those axis lines, and that helps it, so the arrows, so that helps us pick out where our center is. Okay, so we're going to plot these points. So positive 3, 1, 2, 3, positive 2, 1, 2. And that is my A. And then 1, negative 2, that's my C. And they say determine the other diagonal. So this is a diagonal, not the side of the shape. So this right here is a diagonal. Just getting my straight edge. So this right here is a diagonal, not the side. So meaning that, and they said of a square. So what they're saying is, so now A is over here. So A, B, C, D. That's a diagonal. We're looking for the other diagonal, right? That's what's going on. Because A to C is diagonal. So we know that B is somewhere over here and D is somewhere over here. So that's a diagonal. So that means that the slope has to flip. So how did we get from C to A? We did to the right, so rise over run. We did, we went, well, first of all, find your center. Find the center. What's the smack dab in the center of that? Right there. So if you look at the right triangle, I'm making I went up 4, I ran 2. What's half of 4 and 2? That would be 2 and 1. So that's the middle. Okay, so we know that the other diagonal has to cut through that, and we need to make a right angle when we make those lines. Okay, so find the center, and then look at the slope. So if I went rise 2, run 1, so look at the slope from the center. So right now we have positive 2 over 1. So up 2, ran 1. So now we want to do the perpendicular, which would be negative 1 over 2. Flip the sign and flip the fraction. So from here, I want to go down 1 and run 2, 1, 2. Okay, and then continue that pattern. So do the undo of that one. Rise 1, back 2, rise 1, back 2. And those are your other 2 points right there. So and does that look legit? Too legit, don't quit. Hey, hey. Yes, it does. That looks legit. Okay, so one of those would be your B, and the other one would be D. It doesn't matter which one's which. So your other 2 coordinates are 1, 2, 3, 4. So 4, comma, negative 1. Your other one is 0, comma, 1. 0, comma, 1, because it's on the y-axis, so it's with the y. So those are your 2 coordinates. 1, 2, 3, 4, negative 1, and 0, 1. So those are your 2 coordinates. So this is probably going to be multiple choice for you. So if they give you A, B, C, D, I would just try the two coordinates and look at which ones look the prettiest. So just utilize the multiple choice to your advantage. All right. Okay, and then number 18. All right, so on number 18, Ashanti is surveying a new parking lot shaped like a parallelogram. She knows that there are 3 vertices of the parallelogram, A, B, C, D. So let's start in the axis lines. That'll probably make life a little easier. Okay, so we're at 0, 0. That's my A. We're at 5, 1, 2, 3, 4, 5, positive 2. That's my B. We're at 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's my C. Okay, so if I go A, B, C, D would have to be somewhere over here. So it's not here, it's not down here, because that would still make a parallelogram, right? But I want to go in a circle, so it would have to be somewhere over here. Okay, so we just need to figure out what the pattern is. Okay, so I know, let's see, if I go like this would be parallel to that. So those two would be parallel. So how I get from B to C, that would be the same thing as A to this missing part. So I'm just going to figure out what that pattern is. So if I look at this pattern, I went to the right one, and I went up 1, 2, 3. So to the right one, up 1, 2, 3, there would be my new point, and that would be D. So I'll make little dotted lines to help myself out. And that looks legit. So D would have to be at 1, comma, positive 1, 2, 3. And that's your answer. So 1, 1, 3. Okay, keep going. All right, number 19. All right, let's plot the points. So let's start on our axis lines first. That usually helps us out. All right, so 19. So negative 5, 1, 2, 3, 4, 5. Positive 6, 1, 2, 3, 4, 5, 6. There's my A. 6, 1, 2, 3, 4, 5, 6. Positive 6, 1, 2, 3, 4, 5, 6. There's my B. 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 3, 1, 2, 3. There's my C. Negative 3, 1, 2, 3. 1, 2, 3. So negative 3. Boom. There's my D. All right, let's connect the dots. Okay, so we have this picture. And if you can't really tell what it is, maybe you want to darken it or add some colors to this. That might help. So I still have my other line there just to know where actually the line really is, but this is just making it a little more colorful. Okay, what kind of quadrilateral is this? Okay, just look at it. What do you think it is? So of your choices, what do you think it is? So I'm looking at this. I know it's not a rectangle, and it's definitely not a square because those are not 90 degrees. So it's either going to be a rhombus or it's going to be a parallelogram. Okay, so what you can do is you can take the corner of your paper and measure this. This only works if you're actually using graph paper. So the question is, are those sides equal to each other? So I'm making basically a ruler, and is that equal to this side? Nope. So I went a little more over. So that is definitely not a rhombus either. So I'm pretty sure this is a parallelogram. So, but let's just double check. So my guess is the parallelogram. Boom, done with this problem. But let's double check. Okay, so we're going to measure this. Okay, if we measure this, this is straight up, you can count the hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's just 11 hops. And right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's also 11. Awesome. So far, so good. Now we just have to measure this one. Okay, so that one right there, that's 2 squared. So 2 hops by 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is a 2 by 9. And if you put that in the calculator, 2 squared plus 9 squared we get 85. So square root of 85. Okay, so right here, that's the square root of 85. And over here, do the same thing. And guess what? That is another 2 by 9, which is definitely square root of 85. Okay, so the sides are not equal, so this definitely is a parallelogram, which I guessed right at the beginning before I even did any work. So isn't that awesome? Ooh, look at this, guys. We're on the last page. Fantastic. All right, so here we go. So let's start in our axis lines. Okay, let's plot our points. We're at -5, 1, 2, 3, 4, 5, and +7, 1, 2, 3, 4, 5, 6, 7. There's my M. +2, +6, 1, 2, 3, 4, 5, 6. There's my A. 1, 2, 3, 4, 5, -3, 1, 2, 3. There's my T. Okay, and this is X, Y, so on the X-axis, I'm at -4, so 1, 2, 3, 4. And that right there is my H. Okay, so let's connect the dots. Okay, so look at that little beautiful thing. Look at that birdie. Look at that beauty right there. Okay, so I'm looking at that. That is definitely not a rhombus. That is not a square, none of that, right? However, if I turn it this way, what does that look like? That right there looks like a kite. And so these two sides should be equal, these two sides should be equal. So let's double check. So those sides should be equal to each other. Let's double check that. Okay, so if we measured this, that is a 1 by 1, 2, 3, 4, 5, 6, 7. So 1 squared by 7 squared, and we got the square root of 50. So right there is square root of 50. Right here, we got a 1 by 7. That's the square root of 50. Down here, okay. Down here, we have 1, 2, 3, so that's 3 squared. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 9 squared. So 3 squared plus 9 squared, we get 90. So square root of 90. And right here, make a right triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, and 1, 2, 3. So yeah, that's also square root of 90. Okay, so if we look at the rules of our parallelograms, sorry, not our parallelograms, of all of our quadratics. So we're looking for page 4. Here we go, kites. So that would be this and this are equal, this and this are equal. Awesome. So this sucker is a kite. So determine the most specific name for this. Kite. All right, we are almost done, guys. Okay, so okay, number 21. So same thing as this picture right here. So we're looking at this. All right. So we're looking for, so now that we know this is a kite, we're going to be looking at the rules of kites. So we're going to be looking at the rules of kites. So diagonals bisect each other. So diagonals bisect each other. Just one moment. Got to do something real quick. Meeting will start. Alright, okay, so diagonals bisect each other. Okay, so is that true? So let's look at our rules for that. Okay, do the diagonals bisect each other? So does this diagonal and this diagonal cut each other in half? So just look at the rules of the kite. So I'm just going to exaggerate the picture of a kite. Does this, and so I know that my two arms are equal, but does from my head to my heart equal my heart to my feet? No. Are the diagonals perpendicular? Do these diagonals make 90-degree angles? Yes, because your heart is always right. Diagonals are congruent. So are the diagonals congruent? Does this entire thing equal this entire thing? No. And diagonals are opposite, bisect the opposite angles. So my eye equals my eye. I agree. My foot equals my foot. Does my thumb equal my fingers? No. So those would be the answers. All right, 22. Quadrilateral LEF. So we have a rhombus. So all those sides are equal. I'm trying to be as accurate as possible here. Okay, so all those sides are equal. So and I can just use my rules right here. So which is false? That's what they want. So all sides are equal. Yes, that's true. Now, a lot of you guys are like, oh, okay, boom, we're done, because you're like, oh, that's the right answer. But if you keep going, I want you to check all of your answers. So diagonals are perpendicular. Hey, look at that. That's one of the rules. All the diagonals are perpendicular. That's also true. So look, we have two correct things so far. Oh, they're looking for the false. Okay, opposite pairs of sides have the same slope. So opposite sides have the same slope, meaning that they are the same slope means parallel. That's what that means. Well, first and foremost, a rhombus is a parallelogram. So opposite sides are parallel. So that is also true. And then corresponding sides are perpendicular. So sides next to each other are perpendicular, meaning they meet at a 90-degree angle. No, that would be a square. So this one is false. So the answer was D. Okay, number 23. So, all right. So number 23, we have, there we go. Okay, so number 23. Okay, so first of all, this is a parallelogram. Awesome. They also said that BC is equal to AD. Just start marking stuff. BC is equal to AD. Awesome, just mark it. And AB, so I'll put a double in here, is equal to DC. Mark it. I have no idea what's going on. I'm just marking stuff. AC is equal to CA, so 1, 2, 3. And the triangles would be equal to each other because it's side, side, side. Now, why would B equal to D? Once you prove that that triangles are equal, what's the final step? Was always that final step, and that would be CPCTC, and that right there would be right here. So you just said triangles were congruent, so it probably has something to do with triangles being congruent. So it's C. All right, and last problem. Okay, so let's just go through the motions again. All right, so they said a given. What was our given? A, B, C, D is a parallelogram. Okay, so that would be C. So that's C. So we got that one squared away. All right, then AB is equal to DC. Okay, we just said something was equal. Mark it up. AB is equal to DC. Now, why would these two be equal to each other? It probably has something to do with the fact that you said a parallelogram. So we're talking about sides being equal. In a parallelogram, opposite sides are congruent. That sounds pretty good. In a parallelogram, diagonals, those are not diagonals. So so that would, the only thing that worked would be B. So in a parallelogram, opposite sides are congruent. Okay, then the next thing, in a parallelogram, diagonals bisect each other. So we're probably going to be talking about diagonals. So we're going to be saying things are equal to each other. So this is a statement, so we're going to say something is equal to something. The only thing that works is AE, put a double here, is equal to CE. That's the only thing that works. That's the only thing that's talking about diagonals. So AE is equal to CE. That's A. Okay, then they said DE is equal to EB. All right, so 1, 2, 3, 1, 2, 3. Now, why would those two be equal to each other? And that would be D, because in the parallelogram, diagonals bisect each other. Same thing as what we just said a second ago. Diagonals bisect. So that right there was D. And finally, you just right here it says side congruency. So that definitely is going to be a triangle is equal to a triangle. And the only one that works is E. So triangle ABE is equal to triangle CDE. And remember, the last thing you're always going to write is what you're trying to prove. That won't be a reason. It will always be your statement. So, and there you go. All right, that was everything you needed. That was an hour-long lesson. All right, I hope you guys have a great and wonderful day and prepare for the test. Thank you.